long. It depends on the situation, okay? But I need to discuss the condensation, sublimation, deposition, solidification, and the fusion. Okay, processes. Okay, because I already discussed evaporation and vaporization in the afternoon, right? Then I have to proceed with the condensation. Okay, condensation is a process from change, okay, from gas to liquid state. This is the reverse of evaporation process. Okay, condensation. Okay, so I will write now here latent heat of condensation, right? Latent heat of condensation. Okay, latent heat. Ay, sorry. Exothermic na kayo environment. I have to on the AC. Okay. Oh my gosh. Okay. Latent heat of condensation. Condensation. Ganon. Okay, what do you mean by this? Okay. Meaning to say this is the amount of heat that is being released, okay, being released or is being given off for a 1 mole of a substance when the liquid is condensed. Okay, because it's condensation. Liquid is condensed at 100 degrees Celsius at standard pressure. It's kind of like that. Because we are getting the heat here, your definition will always be heat in the numerator. But actually, guys, you can have your own definition if you have the unit of the value of this latent evaporation. Okay? Like for example, the latent heat of condensation of water at let's say, okay, 100 degrees Celsius, right? And then, what is the latent of condensation of water? So that is the reverse of the latent heat of vaporization. So, you have now negative 2260 kilojoules per kilogram as your latent heat of condensation is simply the reverse of your latent heat of vaporization. Okay? It's very clear. And I have also 40.8 negative also. This is just the reverse, right? 40.8 kilojoules per mole. Since the denominator is small, so this is molar latent heat of condensation. Okay? Like that. So we have now two values here. Okay. Now in terms of calorie, that is 530 calorie per gram negative. So this is negative 530 calorie per gram. But actually how you can convert kilojoules to calorie, it is not an issue. Just use the conversion factor. 1 calorie is equal to 4.184 joules. Okay? Like that. It's easy for you to convert. Okay? If you like also to memorize also. It depends on you, huh? Okay? Like that. Now, what do you observe with the unit, guys? Okay? So, just incorporate in the definition. Okay? Like that. Okay? So the quantity of heat energy released, okay, per mole of a liquid substance water, okay, that will condense at 100 ganun siya at 100 degrees Celsius and standard pressure. Okay, something like that. Okay, condense into liquid man siya. Okay? Ganon. So, write it down here. So, latent heat of condensation, we still use also the delta H. It doesn't mean that this is a condensation, we no longer use the delta H. Okay. First law of thermodynamics, sorry. Okay. Delta Q or delta H is equals to delta U plus pressure times the change in volume. Okay. Let's assume that this is, not really assume guys, kasi the unit is negative naman siya, no? This is exothermic reaction, right? If we have a negative heat energy released, or enthalpy of formation of this chemicals, something like that, or purely water, okay? So like that, okay? So we need to substitute now. So this is exothermic, okay. Negative 530 calorie is equals to the change of internal energy plus P times delta V. So ang problema ni mo, internal energy na lang, ganyan siya. Then if the problem have data, then we can substitute and solve what is being required. As easy as that. What the problem is if it undergoes analysis, that's the more difficult part of problem solving, okay? Something like that. Because not all problem solvings are the same all throughout. There is also problem solving that is very distinct or unique, that is not the same for others. Okay, then it is your first time to encounter that kind of problem. Okay, and you will face that on actual. So how can you manage that one? Something like good that if the problem solvings are you meet that before and you practice that several times. What if the problem solving is not really that familiar to you? Okay, so that is the time you will apply the analysis. Okay, you check your comprehension regarding theories and concepts and formulas that we presented, something like that. Because the analysis level will depends on the individual, mental capability. Okay, we should not having at the same level of IQ. That's the main difference. There's others also very fast. Okay, there's others who are very slow. There are others who are average. So that's why we will try to develop this basic concepts and theories so that it will be fine. Okay, something like that. Okay. The more we will do that, especially if our IQ is not that very, superlative. Charot. Okay? Nakaloka. So, if we try to put that here, delta H, so latent heat of condensation is equals to the change in internal energy, delta U, plus the pressure, that's the change in volume. Ganun siya. That's condensation, okay? And now we go to fusion. Latent heat of fusion. Wow, bongga. Latent heat of fusion. Okay. This is a process of changing the solid into liquid. Something like that. Okay. This is fusion or melting. Okay. So our latent heat of fusion is simply defined as the heat required, okay, in terms of joules or in terms of kilojoules, per quantity of kilogram or gram of liquid water that changes the phase from solid to liquid. Okay, I'm just having my own definition through the unit. Okay, this is the unit, right? Like this, and you are dealing with phase changes. If you understand the phase changes, then you will only construct your own statement, okay, in having the definition through the unit, okay, and understand also that the heat is being released, right? It's being released or the heat is being absorbed, and use that in your own definition, something like that, per quantity of the ganon, since we know that liquid water, and ganon siya, okay, and a state from solid to liquid. So, you can have your own statement na siya talaga, okay? You can have your own definition through the unit expressed. So, the latent heat of fusion is equals to 79.7 calorie per gram. Okay, 79.7 remember, this is for the latent heat of fusion. 79.7 calorie per gram. Because the basis is 0 degrees Celsius. Okay? Originally, the ice starts at 0 degrees Celsius, right? Like that. It will freeze at 0 degrees Celsius. Then when it melts, of course, the temperature will increase. Reverse man siya. Okay, sa evaporation, something like that, okay? Sakto ba? Solid to ano siya? Solid to liquid. Okay, then at solid phase, the ice has a 0 degrees Celsius freezing point, right? Or 32 degrees Fahrenheit. Then it will, somewhere along the way, it will melt. And it will become a water. Of course, the temperature will no longer be 0. Okay, it will increase, right? But not necessarily 100 degrees Celsius because you didn't boil that one. Okay? At least it will reach to a temperature which is at room temperature. If you will put the ice in your room. Okay? For example, this I have a refrigerator and I have to get the ice inside my refrigerator. Let that melt by its own. So it will receive the temperature of my air conditioning, something like that. And later on, it will develop the, let's say, I have a temperature of my AC which is 22 degrees Celsius. It will also receive the same temperature that's circulating inside the room. But it could never be 0 degrees Celsius anymore because it is melted naman talaga siya or changed into liquid. Okay? That's the logic there. Okay? For the latent heat of fusion. Okay? Same, use this formula also. Delta H is equals to change of internal energy plus P times the V. Okay? So this is positive. So, if this is positive, this is spontaneous. Oh no, non-spontaneous, sorry. Okay? Like that. So, ganun pala talaga siya, guys. We will just notice it if it's spontaneous or not so that we can easily understand right away, right? If there's a delta H. This is also delta H, but delta H of fusion. Okay, I will show you delta H of fusion. So, I will just put delta HF. Okay, so I will just put delta HFS because there's also delta H of formation which is also delta HF, right? So to make it different, delta HFS meaning the latent heat of fusion or the change of enthalpy at fusion. Okay, like this, delta HFS. Okay, the other one is delta H condensation. So delta H small letter C. Okay. Delta H small letter C. So delta change in enthalpy at condensation or latent heat of condensation. No need for the vaporization because it is the common of all. It's always the evaporation, it's the common of all. Common. So I have to put here solid to liquid, right? This is fusion. Okay. Here also is condensation. So this is the reverse, liquid to gas. Condensation. This is enthalpy change of changes phase man, ha? Enthalpy of change phase. Akong topic. Okay, liquid to, sorry, this is the reverse. This is gas to liquid. Okay? Ganon. So, number 3, sublimation. Oh my gosh. In our chemistry, the definition of sublimation, it is a change from solid to gas. The specific example for that, as far as I could remember, is a naphthalene ball. The white color, and it will remove the bad odor if you put that in your cabinet. Something like that. Okay, if there's very, the odor is very bad, then you have to put this naphthalene ball. Naphthalene ball is a solid, the white one, right? And it will become small later on, and it will just be consumed, and it will evaporate into as a gas. So, a change from solid to gas. So that is sublimation. So the naphthalene ball will undergo a latent heat of sublimation, or the enthalpy change of sublimation. So we'll put here, latent heat or heat of sublimation. It's just the same, huh? Latent heat of sublimation. Now, since we are repeatedly using the word latent here, class, then you'll say, what is latent all about? Then it's latent all about. It is an adjective, it is a pronoun, it is a verb, it is a collective pronoun, it is a preposition, it is a conjunction, like that in English. you have to understand also, it is a third personal pronoun, mga ganon. Okay? What is this all about? Oh, because it's usually used. Okay? So is this really an adjective that this so that we can, kaya pala, because that is the meaning of Latin. Okay, check. This is common to all. Even though the phrase changes are different, but we use the word Latin. So what is this all about? Ganon. So it will create you curiosity and you have to research. Okay? Okay, that's also one quality of a scientist, very observant, and then if they found that they cannot understand, they will dig into it deeper, something like that. Okay, so nobody pushes them to do that, but it's actually inherent characteristic of a scientist. Okay, very observant, and then a very high critical thinking, and also a very high level of inference. You know, in science, inference, okay, the gathering of data like that, and through critical thinking, data gathering, something like that. So those are the quality of scientists. But still, they have to employ the scientific method in their scientific research, something like that. So research the word latent for your assignment. Okay, so we have sublimation. Okay, solid to gas. Okay. So I have to put enthalpy change, delta H, HS. Right? Small letter H lang siya. So HS, delta H, HS, meaning latent heat of sublimation. Again, use the same formula. Delta H is equals to delta U plus P times change in volume. Okay? Like that. So if the unit of your latent heat of sublimation, in which I don't memorize what is the constant for this latent heat of sublimation water, okay? I don't memorize because I only memorize the common. Okay? I have to still research this one. Okay, sublimation man siya. Okay? So I think it's just the same with ice, right? Because if we try to put that in a naphthalene as a solid, and it's also an ice as a solid, and it will become a gas, like blah blah blah. Wait, maybe it's not the same, okay? Let's do research for this, Another assignment, research what is the latent heat of sublimation constant of water. Because all I know is condensation at saka evaporation lang siya, at saka fusion. But sublimation, I don't know, okay? I change from solid to gas, okay? Take note, guys, if you can obtain the latent heat of sublimation, the latent heat of fusion, the latent heat of condensation, you can determine if it is an exothermic reaction right away or endothermic reaction right away. Okay, whether it is an endothermic, exothermic, spontaneous, non-spontaneous. Now, if it is negative, then you can substitute this equation, and then it changes the formula, right? If you substitute the negative here, right, it will change. You get the point? So if you try to solve the delta U and the negative delta H, then it will be transposed. So we can come up another sign and solve the formula. It matters siya if negative. Okay? Something like that. Okay, that's sublimation. Now, the reverse is gas to solid. Ito talaga siya. Difficult. Okay, latent heat of deposition. Charot, okay? Latent heat of deposition. Okay. So the latent of deposition is just latent heat of desublimation. So guys, where can we use D? The word D meaning removal. Okay, for example, dehydration, removal of water. Okay, like that. Degeneration. For example, degeneration of protein in the glycolysis process. So meaning to say, you don't generate the protein to be able to be used up in the glycolysis reaction. Like that. Okay? So degenerate, the word D meaning removal siya talaga. So if we have sublimation, the reverse will be desublimation. Okay? Because you don't want sublimation process to appear. You want that to remove, that's why desublimation. It is the reverse of the sublimation. Yes, sublimation. This is gas to solid. Very difficult. My gosh, what's example for this? gas to solid. Laoy, nakakaloka. Oh my gosh. Let's think what's the example for this. Gas to solid, guys. Gas to solid. Oh my gosh. Ganon. Let's check. Okay. For example, there are a combustion reaction, but okay. Wait. Kaloka? It's very difficult really to think an example for this. Okay. Oh. Ay, muagi siya og liquid. Okay? Muagi siya og liquid. Liquid to solid pa siya. Muagi siya liquid. Muagi siya solid. Una siya mahimong gas. Okay? Gas siya. Gas first, it will change to liquid, and then liquid to solid. It's possible. Two process. It's not direct, right? Because it's really impossible a gas will become solid right away. I don't meet this kind of phase change in my entire life as a chemical engineer. Something like that. Gas to solid. Anybody help me? Okay? What I understand, it will change first to liquid and then baden liquid to solid. Because it's easy, right? Solidification na siya talaga. But at first, it starts with a gas. So meaning to say, for example, vapor, like that, and then the vapor, it will turn into a steam. You know steam? S-T-A-M. It will become a moisture. Moisture, meaning a wet, liquefied steam. Moisture. And after that, it will go to solid. How come? Yes, because if the temperature of, let us say, if the steam will be deposited in the pipeline, which is an endothermic reaction, very cold environment, then it will become solid, right? It will freeze. Okay. Just like in water treatment. In water treatment, there's a scaling process, right? Scale, which is normally calcium, I think so. Hardness, the total hardness of water. Okay, in water treatment, chemical analysis, we have that, right? The suspended solids, the total hardness, the calcium, the iron. Okay, we can determine the parameters of water. So let's say if the gas will turn to liquid and then liquid to solid. I think it's possible, but it's a rare case. Rare case lang talaga siya. Okay? Because unless siguro if the pipe have a sort of, what do you call this one? Erosion. Erosion or corrosion. Corrosion process in which the water will escape to the outer layer of the pipeline. It will develop corrosion, right? It will produce ferric chloride, something like that. And at first, it's steam, gonna react to, the calcium or iron, and then baden, it will become a scale. Okay, scale, SCA. Scale deposits usually contains calcium and magnesium. Okay? But corrosion consists of iron talaga siya. Reddish brown accumulated in the outer layer of the pipeline. So corrosion process or scaling process in water treatment, right? If you can see that in the pipe, it will develop after 3 years ago, 4 years ago, it will develop so many. And the thickness will also increase as the number of years will rise. Okay? As the time increases, this scales deposits also will increase if there's no preventive maintenance or preventive cleaning maintenance of these pipelines, something like that. Okay, unless there's regular cleaning, then it will be removing the scales, and we have also to remove that by putting, I think so, hydrogen peroxide, H2H2. Then it will remove the scales or the corrosion, I think so. I'm not really sure, or it could be muriatic acid to remove those corrosion scaling, so and so. Okay, just like or the H2O to hydrogen peroxide. Okay, like that. Okay, stain removal or stain remover liquid. Okay, Let's have that general na lang. I don't investigate the fuel regulation for that. As long as it is stain remover. A liquid that has the capacity to remove the stain. Ganon. Okay? So latent heat of deposition gas to solid. Again, use this formula also. Delta H plus P times delta V. And then I have the symbol of delta H. Saan naman eh? Delta H D. Delta H small letter D. So deposition. Okay, oh perfect. Because it's also D sublimation. So delta H subscript letter D. Meaning desublimation or deposition. Nagkataon lang. Because the first letter is D. Letter D, small letter D. Okay, number 5. Deposition, solidification. Latent heat of solidification. Oh my gosh, number 5 na ta. Okay. Solidification, meaning, okay, solidification, liquid to solid. Okay? Latent heat of solidification. Solidification is very common. Okay? In metallurgical engineering, in mining, like that, in alloying, alloying process of different metals. We mix together at a certain high temperature, right? It will be melting each other and it will produce another high quality type of metal, something like that. Alloying. Okay? Example is the roof, the metallic roof that we have in buildings or in our homes, that is galvanized iron sheet. So it is a combination of iron and zinc, something like that, right? We alloyed the iron and the zinc mixed together at a certain temperature. So this is also an example of solidification, right? Because the end product is a solid man siya. Okay? From liquid into solid. Okay? Like that. So liquid metals at certain temperature. Meron siya, such as mercury, right? So mercury can be liquid originally first. That's why it's used in the thermometer bulb, right? To measure the pressure of the blood. Thermometer bulb. So that's liquid. Can you see the level there? Like that. The level there is liquid mercury. Okay? Liquid mercury. And then it will, change its phase also. Ganon. Example lang siya na to prove that there is a liquefied metal originally at a certain temperature. Okay, of course, at a certain operating conditions and parameters. Okay? Like that. So, latent heat of solidification. Okay, latent heat of solidification. Ganon. Solidification. Okay, so it will be a change from liquid to solid. Okay? Liquid to solid, diba guys? O, ganun siya. So, delta wala, naroon ba tayo S ganina, no? We will try to use another symbol. So, delta H, SO. Because you have also delta H, S for the sublimation man. So, we need to change this one to delta H, SO, meaning solidification, a change from liquid to solid. Just to make it different kasi pareho siya. Okay? Delta H SO. Wow, safety officer SO. Charot. Ganon. Okay. Delta H SO. Oh guys, come on! Nakakaloka! Okay? Now, why I emphasize that phase change? Because we need to understand also the constant heat of summation. Wow, constant heat of summation? Nagkaroon ba? Or the enthalpy change of the reaction. Okay, now let's go one by one na. We will not include the vaporization because it's very common. So, the heat of formation of the reaction of the vaporization is very easy. Okay, the enthalpy change of water, okay, at liquid, okay, minus the enthalpy change of liquid as a vapor or a gas. Ganun siya. But we will go directly to the condensation. I know that this is condensation is gas to liquid. So we will say delta H of the reaction of the condensation. Okay, delta H condensation reactions, I have to put R, X, and C because the abbreviation of chemical reaction in science is RXN. RXN, meaning reaction. You can find that also in the labeling of some medicines. They put that RXN, meaning the formulation or component, something or ingredient, something like that, RXN. Okay, so that is reaction or chemical reaction. So I have to put RXN, delta H RXN, then subscript C, because this is condensation. So delta H RXN C. So this is enthalpy change of the reaction of the process known as condensation is equals to, because it is a change from gas to liquid, is equal to the enthalpy change, okay, enthalpy change of a gas, okay, to and minus delta H of a liquid. So let's specify na lang talaga ang phase para sure. Okay? Delta H gas minus delta H liquid. Now if it is given in the problem, then we can compute easily. Okay? What is being required? So in a problem solving, for example, ethanol, 1 mole of ethanol has an enthalpy formation of blah blah blah. What is the enthalpy change of a liquid ethanol? Ganon. Or what is the enthalpy change of an ethanol in its vapor state? Oh, ganon. So you mean to say you have to compute for delta H gas. Since you know the delta H formation given in the problem, and you found also the delta H formation in the table here, like this, standard at 29 Kelvin, this one, then you can compute automatically the delta H of a gas or the delta H of liquid, even though the unit, the data is only one. Okay, that's why I told you, don't be afraid if the problem is having only a data only one. Because me also, when I was a student before, I will be afraid if, oh my God, the unit is only one. Because most of the formulas having 2 or 3 quantities, mo talaga siya. Then I found it difficult. Oh, why? It's only one. So it needs you to think that there are also standards to be applied. Okay, and this honestly, and I found it difficult. Okay, even though the problem is just very basic, and then I found it difficult because due to the fact that it's only one given, I am not pala very aware that this is there's a standard pala talaga siya. Okay, values for that. Okay, okay. If it's just only be good if the instructors are really teaching, but most, I think most or a few instructors in college are doing very fast, or shall we say focusing more on the problem solving, okay, and failed to stress out the basic theory. Okay, that's also the main reason. That's why I keep on reading books in the library, because I cannot understand very well. Okay, and then they will go directly to problem solving. Okay, then I will be shocked already because I am not good in mathematics, right? As I told you. Okay, so that's why. Okay, so this is the latent heat of condensation. Now, prangkahan na tayo. If you are not really good in mathematics, then devote yourself to study. Okay, and develop the culture and habit of memorization. If you think you are not really good in mathematics, okay, magsabot tadaan. If you're trying to take an engineering course, okay, if you are not good in mathematics, okay, saktura ka or below, then have a habit of studying that much, memorization, okay, so that you can develop and practice to solve problems because you have already the basic concept and theory in your brain cells. Okay, so that's the technique, ha? Okay, don't be afraid that if you're not good in mathematics, you will not become an engineer, something like that. Okay, gusto kayo mo discourage ang uban. Okay, sure ko ana, 100% sure. Okay, pagtanaw gani sa grades, and then the child has very low in math, like this, and then the child want to become an engineer, the parents will say, no, never take up engineer because your grade is very small. But then the child is very, he's really want to become an engineer. So because the parents told them, him or her, don't take this because your grades in math are not that high. So this child will no longer also take the, this engineering course. So it's not like that, okay? That's a wrong mentality of parents, okay? Just let them, decide what's their course they want really, okay? Something like that. Because if they want that, then they have the passion to study for it. And they have to go for it, something like that, okay? They have the passion to study that kind of course because they love or they choose that to be their course. Do not force them to take a course in which in the first place they don't like. Because if they don't like, they don't have the courage to study that much. Okay, they don't have the interest to study that much, and it is not also good that if they're while they're still in college, let's say 4 years, 5 years, they don't like. So it's not good also for students to do that just because of for the sake that their parents wanted them to be like that. Actually, that is wrong. Okay, let them decide what they want for their career or for their course, so that they can really excel for their passion to study more in courses that they love the most and they like the most. Okay? Something. You can act only as a guidance, but never decide for them what course to take. Okay? Something like that. And then it happens that the course you want to suggest them that your child also like, then bingo, it's fine. There's no issues about that. That would be better, right? But my point is, if the child don't really like what you decide, of course, then don't force something like that, okay? So there's a chance that he or she will fail really to the particular course, or her or his grades will become low because he or she don't have the interest to study that kind of course. Okay? Because I also have a friend before, a colleague in Qatar, he's working also in safety, something like that. His course is a license. He's really a licensed nurse. Okay, but when he's working, he don't want to become a nurse. Okay, he is a safety officer like that. But because they don't like to work being a nurse, but just because his parents want him to become a nurse, he did everything, he studied, and he even passed to become a licensed nurse or registered nurse. But at the end of the day, he don't work as because he don't like. Okay? So see? So things like that, it's not really also healthy for your child in deciding what course to take. Okay? So, going back to business. Number 2, latent heat of fusion. So this is a change from solid to liquid. So delta H. Ganon. Doon sa nang orasa, uy. Oh my gosh. Kaya matug na ko. Magkatugo na lagi ko. In fairness. Ito pasa. Mundoka na ko eh. So delta H. Fusion guys. So ano lang siya. FS. Right, as I told you earlier. Okay, then delta H. So liquid. Okay, enthalpy change of fusion of the reaction is equals to the delta change of enthalpy of solid minus the enthalpy change of liquid. Now we go to sublimation. So delta H, Rxn, sublimation, I said small letter S, right? So delta H, sublimation, solid gas, then this is delta H, solid, okay. Because I fusion, I did not have the vaporization man talaga. Okay, I eliminate the vaporization because that is most common man talaga siya, diba? So delta H, okay, solid, minus delta H gas. So this is sublimation. Enthalpy change of sublimation, or heat of sublimation, or latent heat of sublimation of the reaction is equals to delta H of solid minus delta H gas. Now we have the deposition. Laoy. Delta H Rx and deposition is letter D, right? Deposition is equals to deposition is a change from gas to solid. So delta H gas minus delta H solid. Okay? This one. This is enthalpy change of the reaction of the deposition of a reaction. Okay, is equal to the enthalpy change of a gas minus the enthalpy change of a solid. And then the last will be the delta H of the fusion. Not a fusion, solidification. Okay, delta H Rxn. So I have solidification, right? SO. Oh, equal to. So this is liquid to solid. This is solidification man siya. So delta H liquid. Okay. And then delta H solid. Okay? Muna ni siya, guys. Okay? There are 6 pala siya talaga. Okay? But we take into account lang the most common, ha? Okay, which are the evaporation, condensation, like that. Okay, sublimation, deposition, solidification, and fusion. Okay, effect. We put only the phases. But if the problem will say, for example, aluminum chloride, then put also the aluminum chloride there, and then put the subscript G for gas to make it easier, and put the subscript S for solid, and put the subscript solid S. So S for solid, L for liquid, G for gas in a small letters. Okay, then put first the compound. For example, delta H of acetone. So delta H, the formula of acetone, and then subscript the gas G, small letter G. Okay, then minus the delta H of the formula of the acetone, and then the small letter also of the, let's say, gas, let's say, I don't know, solid. So S, small letter S. So that is very easy to solve. It will take time also in putting the words too much. Okay, so that it can save time also. Okay, SMG all the time because this is enthalpy change of phases man talaga siya. So this is more general, ha. Not yet specifying the type of chemical to be used in a chemical reaction that undergoes the phase changes. Okay, so that's the purpose. Now you will apply na this. But most of these guys have values talaga siya here. Okay? And then if 0, we are very lucky. It will reduce to our formula. Then we will be very happy to that. The more it has a very less data, the more we'll be happy. Because sometimes it leads us to confusion, and sometimes it will complicate us. Nobody wants also to have that too much data. Okay, who wants to love that? Maybe the intelligent, the genius, they want to be more challenging all the time. They did not want to solve a simple problem already. Always difficult, but we don't want also to happen that to us because for the reason we don't have a very high IQ compared to them. Okay, okay. Let's not be ambitious. Just leave that to them. Okay, like that. Okay. We will just focus on the average. Okay, accepting or receiving the academic information. Okay, because them without explaining this, they can really understand. Okay. Because their minds are very fast. Mental ability is very superlative. something like that. That's why they did that study na talaga in sometimes. Okay, but they're very quick really sure, 100%. Okay, especially the magna cum laude, graduate with honors, okay, the dance listers, something like that. Okay, they're very quick and fast in IQ, especially numbers, okay? If engineering course, numbers which lab, okay? Okay, but for those, let's say, honor student and then not really that good in math, usually they will never excel also in engineering because math really is the basic foundation. It cannot be denied. Okay, for example, you are valedictorian in your high school or salutatorian or whatever, you're top 3 or top 5, whatever, and then if you are only an honor student because your other academic subjects are very high, okay, other very high, only the mathematics are not low, are not also high, but in the middle, and when you compute the average grade, you can achieve also a very high, and you will go to the top. Okay, now, if you take engineering in your mathematics, it is okay for that statement. But if you will say, you will not become an engineer because you are not good in mathematics, that's wrong. Okay, but if you will say, you will not be, there's a chance you will not become a cum laude or magna cum laude or this lister if you are not good in mathematics. It is really true also because there's a lot of mathematics in engineering. Okay, even though you study a lot, then your IQ is not that high in mathematics. Okay, not good. Okay, even though how effort you do. Okay, something like that. So that's why, so it's an advantage for an honor student in high school that's very good in mathematics also and good also in other subjects because if they will take engineering really, they will really excel because a lot of mathematics will be there. Okay, plus the other subjects. Now the problem that also, if they don't study that much, okay, so they will not also, you know what I mean. Because even though how intelligent you are, then if you don't have the courage to study more, then okay, you will be passing the grades, but you cannot expect that also you will become a cum laude or a cum laude because those people are really studying. Okay, 101% sure. There's no honor student or there's no cum laude, magna cum laude, that they are not studying in their college. I don't see that. Okay? Because nobody is perfect. There's no Superman in studying in a university or institution. You have really to study even though how intelligent you are, how genius you are. Okay? What I mean for that is people that have a very high IQ originally. For example, I am an instructor and I teach this to my students. There are really students that it will really reflected or in their brain cells, even though they will not write. Okay, they will not memorize. It will really just go in their brain, something like that. There's few like that also. Okay, so very high talaga yung IQ nila. Okay, something like that. Okay. So that's what I mean. Okay, so thank you so much for listening for this short vlog regarding enthalpy changes of phase. Phases, not Facebook ha, phase, PHASE. Phase of matter, solid, liquid, and gas. See, there's a solid, liquid, gas in my expression of chemical reaction here. Okay, thank you so much, guys. You can subscribe my channel if you want. You can also comment down below, okay, if you want, and then you can click the notification bell for some news updates as a singer. Eternal voice, especially sciences talaga siya, okay, and occupational safety and health, and then personal vlogs, a little bit of singing moments, something like that. Okay? But the focus for now is sciences, okay? Like that. Thank you so much. Bye-bye, guys, everybody. See you later. Okay? Wow.